Today we'll be talking on Chapter 5 on exponents, polynomials, and polynomial functions. Section 1 is on exponents. Here are the different rules of exponents. The first rule is a product rule. If mn are positive integers and a is a real number, then a to the m power times a to the n power is equal to a to the m plus n. Here are some examples. 3 squared times 3 to the 4th is equal to 3 to the 6th. 3 times 3 times 3 times 3 times 3 equals 729. And here are a few other examples. The zero exponent rule. If a does not equal 0, then a to the 0 power is equal to 1. Example, 5 to the 0 power is equal to 1. The quotient rule of exponents. If a is a non-zero real number, and m and n are integers, then a to the m divided by a to the n is equal to the a to the m minus n. Following example, 9 divided by 3 is 3. A to the 4th divided by a. Again, you subtract 4 minus 1, which is 3. And then b to the 7 over b squared, 7 minus 2 is 5. So your final answer is 3a cubed, b to the 5th. Negative exponent rule. A to the negative n is equal to 1 over a to the n. Example, 3 to the negative 2 is equal to 1 over 3 squared, which is equal to 1 over 9. Second example, 2x to the negative 4th equals 2 over x to the 4th. The power rule and power of a product or quotient rule for exponents. A to the m times n. Here you have the power rule and you multiply the degrees, so it's a to the m times n. Power of a product rule. ab to the n power is equal to a to the n times b to the n. And power of a quotient rule. A over b to the n is equal to a to the n over b to the n. Here are some examples. Summary of exponents. You have the product rule, which is you add the degrees. You have the power rule, which you multiply the degrees. Power of a product rule is a to the n and b to the n. Power of a quotient rule is a to the n over b to the n. Quotient rules, you subtract the degrees. Zero exponent rule, a to the 0 power is 1. And the negative exponent rule, a to the negative n is equal to 1 over a to the n. Simplifying expressions, here are some examples. You apply your rules. The power of a quotient rule, then your product rule, your negative exponent rule, and you get your final answer in simplest form. Section 2, polynomial functions and adding and subtracting polynomials. Here's the vocabulary of polynomials. A term is a number or a product of a number or variables raised to a power. Coefficient is the numerical factor of the term. The constant is the term which is only a number. And the polynomial is a sum of terms involving variables raised to a whole number exponent with no variables appearing in any denominator. Here is an example of 4 terms. The coefficient, the constant. A monomial is a polynomial with 1 term. Binomial is with 2 terms, and trinomial is with 3 terms. The degree of a term. To find the degree, you take the sum of the exponents on the variables contained in the term. The degree of a constant is 0. The degree of the term 5a to the 4th b cubed c is 8. Again, remember that c has a degree of 1, therefore you add 4 plus 3 plus 1, which is 8. The degree of a polynomial is the largest degree of any polynomial. The largest degree here is 3. Like terms talks about combining like terms. You combine like terms with the same degrees. Therefore, this term and this term are the same. You combine those two, giving you the 11x squared y. xy and the xy, after combining those two, is the 2xy, and then combining the negative y and the negative 2y gives you a negative 3y. And that is your final answer. Adding polynomials, you combine like terms. Here's an example. Subtracting polynomials. Again, to subtract polynomials, you add its opposites. So 4 minus negative y. So you distribute the negative, which becomes a positive y. The negative times the negative 4 becomes a positive 4. So you have 4 plus 4, which is 8, and then the positive y. Here's another example. So in the previous examples, after discarding the parentheses, we would rearrange the terms so that the like terms were next to each other in the expression. You can also use a vertical format in arranging a problem. Section 5.3, multiplying polynomials. Use the distributive property and then multiply each term of the polynomial by each term of the other polynomial. Then you combine like terms. Here is an example. Number 1, you multiply negative 2 times 3, which is negative 6. And then you'd add the degrees. 2 plus 1 is 3. Again, the 4x squared is distributed to each of the terms. And when you have a binomial times a binomial, you apply the FOIL method, which is the first, the outer, the inner, and then the last, and you combine like terms. Another example, multiplying a binomial squared. Remember that a squared is a times a, so you rewrite 3x plus 4 2 times, 3x plus 4 times 3x plus 4, applying the FOIL method. Your final answer is 9x squared plus 24x plus 16. Here's another example, a binomial times a trinomial. Another example, use the FOIL method. When you have a trinomial times a trinomial, again, you just apply the FOIL method to 3 terms. You can also use a vertical format in arranging the polynomials to be multiplied. Sometimes this makes it easier. Here's your FOIL. So first, outer, y times y is y squared, y times 4 is 4y, inner, negative 12 times y, and then negative 12 times 4, and there's your final answer. Here's another example using FOIL. That completes part A of chapter 5.